Hello everyone, it's great to see you guys joining early. Stay tuned, we'll be starting shortly. Hello everyone, welcome to another session of the Data Hour series. We'll start in 5 minutes. Till then, let's get to know each other. We have put up a poll. Kindly answer the questions. Thanks everyone for joining us today. We'll start the session in 2 to 3 minutes. Let's wait for everyone to join and settle. Session in the data space. We are thrilled to be here with you this evening for a session full of action-packed learning. I'm Kashyap, part of the data science team at Analytics Vidya. For those who have joined us for the first time, the brief introduction to the data sessions. The Data Hour is a series of webinars conducted by Analytics Vidya and led by top industry experts. It is a fun way to understand the concepts of data science, data engineering, software engineering, and blockchain from the leading players in the industry. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is a roadmap to data engineering for beginners. It is a well-known fact that the industries in the 21st century are governed by data. All the major decisions are based on facts and figures driven from data. Therefore, companies are also focusing on building teams which are specialized in the data management and analysis. Data engineering is one such specialization which is in huge demand in the job market. In this data, Abhishek will explain the right path as aspiring data engineers and data enthusiasts can take to become a successful data engineer. He will be covering all necessary points, including demand of data engineering in the industry, scope of data engineering, tools and technologies one needs to know to start with, and a complete learning path to become a successful data engineer. I hope you're excited to attend this data with us. And before we kick things off and I hand it over to the speaker, a quick recap of the housekeeping items. We are recording the session and the recording will be available on our YouTube channel. The link can be found in the chat section. Please use Q&A session for asking any questions you might have during the session and we will do our best to answer them as the data progresses or towards the end. We will be sharing feedback poll towards the end. You are all requested to kindly fill that up before leaving the session. Now, on to our speaker. In this session of data, we have Mr. Abhishek Sharma with us. Abhishek Sharma is a data engineer at Google with 9+ years of experience in data engineering and database. He's completed his post-graduation from IIIT Bangalore. He has worked with top MNCs, early-stage startups, and product-based companies, and been involved in business decision-making with senior management. He has vast experience in designing and architecting software solutions, database systems, and data engineering and machine learning pipelines. You can connect with him in LinkedIn. The link is present in the chat window. We are also hosting this webinar live in YouTube to our official channel, and the channel link is present in the chat window. You can even follow from there too. Thank you. Over to you, Abhishek. The virtual stage is all yours.
Thank you, and I really welcome everyone. So let me quickly share my screen. Okay, I hope is it visible? Okay, so I am Abhishek Sharma. I really welcome all the participants and really thankful for the coordinators to organizing this data session. So in this session, we'll be discussing about a complete roadmap to be a successful data engineer. And this session is for people who are into software engineering or maybe in data engineering already, or maybe who are beginners or doesn't have any experience even with software. So there is no such prerequisite to attend this session. The session is a guide for you to start your journey as a data engineer in the industry, right? So this is the table of content. This is kind of an agenda for us today that we are going to discuss. So the first thing that we should be knowing is what is data engineering. Okay, why is it required? Why data engineering is required? What is the scope of data engineering? All right, and what are the career choices that we have in data engineering? So data engineering is a vast field. Okay, it can have different options for you to start your career, right? So we'll be discussing different career choices in which comes under data engineering. Okay, then during this data, we'll also be discussing about skills required to be a data engineer. Okay, so what are the skills that you need to have to be a successful data engineer? So understanding of databases, data warehouses, and SQL. SQL is very important. If you want to start your journey in any of the data field, SQL is a must-know skill. Okay. Then we also be discussing some other tools and technologies that you should be focusing on if you want to be a data engineer. And towards the end of this section, we'll be discussing about cloud certifications. Okay. So there are different cloud providers like Google Cloud, Amazon Web Services, and Azure, which provide different cloud certifications for data engineers. Okay, so we'll be also focusing on those certifications, and we will be discussing which certification is best for you and which certification you can go for or plan for. And then we will be discussing how to land a job as a data engineer. Okay, so you get all the skills and you know what is data engineering, you know how to do it, you have required skill set, but eventually we want to start a career in data engineering, right? So how and what is the good approach, or what is the best approach to actually land a job as a data engineer? We'll be discussing that part as well. And then towards the end of the hour, we will be discussing any questions that you guys may have, right? So we'll be having an open forum where we'll be discussing all the questions. Then one may have, and as an aspiring data engineer. Okay, so this slide is about me. So my name is Abhishek Sharma. I'm working as a data engineer with Google. And I have around 9 years of work experience in software engineering, data engineering, analytics, data science, and project management. I have also handled teams, multiple teams, cross-domain teams into software engineering, data science, and as general in project management as well. I have also co-founded a healthcare startup. So I have been a CTO of that startup. And I personally love to read non-fictional books, books about autobiographies about people and all that thing. Yeah, so I think this is about me. But now we are going to focus on data engineering. So if you remember the agenda for today, our first question is, what is data engineering? Okay, so before you start a career in data engineering, you have to know what is data engineering. Okay, but before understanding what is data engineering, there is one thing that you should know: what is data? Okay, so data is something which is always there. Data is present everywhere. Even if I'm talking to you guys and you are asking questions, even if I am running, let's say if I'm doing a jogging, if I'm doing, if I'm eating, whatever activity we do, we generate data. The only thing is we need to capture the data. Okay, so the data which is not captured is not useful. Okay, I'll try to make you understand this point, in the next slide, which is just an image. Okay, so here what we can see kind of a bakery, right? So this bakery may have different cakes, different cookies, breads, biscuits, right? So these are the typical items that we see in a bakery, right? And what happens in a bakery, people go there and they purchase things, right? They go there and they purchase items. They may go there to purchase cakes. They may go there to purchase biscuits, breads, and all. Now, do they generate data? Yes, definitely they do generate data. Okay, so if you go to a shop and you purchase something, the shop sold something and you gave them the money, right? So it is a data transaction being happening here. Okay, the only thing is the shop or whosoever the stakeholder, they need to capture that particular data. If they are not capturing the data, there is no use of data. Okay, so data is the data with whatever is being captured is actually information that you can use, or the data that you can use. So let's take this particular example, and I'll give you a problem here. So the problem is the shop owner is having difficulty selling all of his inventory. So let's say he sell 10 different kind of cakes, but customer prefer only 2 or 3 types of cakes. Okay, now remaining cakes is not able to sell, but he is maintaining an inventory. Okay, now he is not able to make a decision whether he need to put more cakes which are not being sold on the inventory, or he should start baking more cakes which are preferred by customers. Okay, he is not able to make that decision. Why? Because he does not have the data. So to take a decision or to make a decision, business needs to capture data. Okay, now this is a small problem that we saw in this particular bakery. Now imagine if this particular bakery is a company who has maybe like a McDonald's, or maybe like 24/7. They may have different centers in different cities, or they may have different shops in different cities, different states, different countries. Now the problem is getting bigger as the business expands, right? If the business is expanding and you are not capturing the data, this problem is going to be multiplied. It's going to increase exponentially, right? So to solve these kind of problems and to make better decisions, we have to store data somewhere. We have to capture the data, and on that particular captured data, we will be making decisions. Okay, so I told you initially, data is present everywhere. Only thing is to capture the data. And once the data is captured, then we come up with data engineering problems. Okay, so I move on to the next slide and we'll see something there. See, so our first question, what is data engineering? Now the question is why it is required. So as I mentioned, data is very vast and it is unlimited. Data is present everywhere in the universe, and it is very, very, very vast. Only thing is we have to capture it properly. Okay, so there is one thing, data has to be captured properly, and there is another thing, data has to be captured accurately as well. Okay, so it is not like you get some time series data and you store it in some fashion which is not usable, right? That data also doesn't make sense. So we have to capture the data, we have to keep it stored somewhere. Okay, then it is useful for business, or it could be useful for healthcare companies, hospitals, banks, even for customers, e-commerce websites. Data is there, but it has to be captured and stored properly. Next point is data is required to make decisions and more often critical decisions. What does this mean? It means once the data is captured, it is stored, the next thing is to make decisions out of it. Okay. Now, when you capture the data, that data may or may not be useful for business. Okay. So what we need to do to make decisions out of that particular data, we need to apply certain logic. We need to apply a certain process. We need to apply a certain transformation on that data. Okay. And when we are going to apply those transformations, we are going to apply those logics, that is the job of a data engineer. Okay. In the third line, we can see data engineering is to extract, process, and store data, which can be used by business owners. Okay. So in the first point, we saw data has to be captured. So first you capture the data, business people or software engineers or whosoever is capturing the data, who is responsible for capturing the data, will capture the data. Then data engineer, what the data engineer will do, or what data engineering is, you will extract that capture data, you will extract a part of that data, or you will extract that particular data which is useful for your business problem. You will apply certain, logics or transformation on that data, and then you store that transformed or processed data somewhere, so that that particular stored data can be used by business owners or stakeholders to make required decisions, right? Now, it is not always business problems which can be solved by data. It can be a life-threatening, situation also. Let's say there is a particular manufacturing unit, and there are certain dangerous activities that happens. They're like some dangerous or hazardous machines, chemicals are being, dealt with there. Now, in those particular situations also data can be useful. Okay, so it's not always business, it could be other domain of life, or anything. It could be anything, it's not just about business. And towards the end of this particular line, we see required decisions at the right time. What does this mean? So there is one activity, you process the data, you extract the data, you process it, and you then store it for business users or business owners to make right decisions. But those decisions has to be made, at the right time. If you are getting the data, but that data is being, transferred to the business owner a little late, and then that data is not useful for the problem, right? So data has to be processed, it has to be captured, but at the right point of time, it has to be delivered also. Okay, I hope this makes sense. So data engineering is a process to extract, process, and store data for business users or stakeholders to make right decisions at the right time. Okay, so after this, we'll be coming up to our next topic, which is scope of data engineering. So I guess by this time, everybody knows what is data engineering, on a brief level. So we just scratched the surface. Data engineering is a lot more, not just capturing the data, processing it, and, storing it somewhere. Data engineering is a very, very, very vast field. Okay. And you may have heard about data science and machine learning a lot, but I would definitely can comment on this, like data science and machine learning, or even a data scientist can't do anything until unless the data is there in the system. Okay, so the role of a data scientist comes a little late. The data has to be processed before it can, be utilized for machine learning, and it can be utilized for artificial intelligence and all those systems, right? Before that, role of data engineering is, comes first. So data has to be processed, and then it can be utilized for machine learning or other stuff. Now, these few points that you see here on the slide. These points describe typical activity or a life cycle of data. Okay, the first thing comes up is data generation. Okay, so first of all, data gets generated. Okay, once data is generated, then only we can do other activities out of it. Even if the data is not generated, we can't do anything, right? So first, and foremost thing that we need is data, and that can be done with data generation. And data engineer does not do data generation. Okay, guys, data engineer does not do data generation. Data generation is done by softwares. It is done by IoT sensors, or it can be done by websites, systems, whatever it is, right? But data generation is some other system which generates data. Then here you can see 4 points that are green in color, right? So these are the typical activities that a data engineer do or data engineer does, right? These are data extraction. So once the data is generated, it is stored somewhere. Now it is data engineer's job to extract or get the data in their own system, in their own environment, so that they can further process the data and get some analytics or insights out of it. Okay, so data extraction is the activity which data engineer does. Then there is called data processing. What is data processing? Data processing is once you get the data, you have to process it. Let's say typical example is like the bakery example that we were talking about. You are getting the sales data. What kind of a processing you can do? You can do a processing of, like, you can do a sum of all the prices which are for a particular kind of a cake. That way it will tell you for this particular cake how many quantities or how many profit or how many sales you did, how much sales you did, right? That is called data processing. This is just a simple, very, very simple example of data processing. Data processing can be very complex. Okay. And there is another thing that if you may have heard about big data. So big data is, again, it needs a lot of compute power and needs a lot of things to process the data, that kind of a data. Okay, we'll discuss about big data and everything in further slides, but for now we will just understand this, like data processing is the next step after extracting the data from the system. Okay, then we have storage of processed data. Okay, so what we do, we generated the data is being generated by some system, then we are extracting the data, we are processing the data, we are storing the processed data somewhere, right? When you talk about storing the processed data, it means you are going to store the processed data in some database. Okay, that could be a SQL database. People who are not aware about SQL, I will assume like there are people who don't know what is SQL, right? They don't know what is a database. They don't know what is a data warehouse. So we'll discuss about these concepts later in the section, but for now, we can understand like it's a system where you can store the data. Okay, so once the data is processed, it has to be stored somewhere, and that is maybe a typical database. Okay, then once the data is processed, data is stored somewhere, the next thing is you have to deliver the data to users. Okay, you have to deliver the data to users. Okay. Okay, I can see a few questions. What is a data point? Is there any data tool for data generation? Yeah, I can take these questions, Lalit, but we'll take it toward the second section of our slides. It is there. Then Venkat is asking delivery of data to users. Okay, I'll come to these questions. Towards the end of the session. Okay, you guys can keep posting your questions in the Q&A section, and once we are done with the topics, we'll go for these questions. Okay, and we'll discuss in detail what is the best solution for these kind of a problem, right? Okay, coming back to the topic, it is delivery of data to users. So once the data is being processed, it has to be delivered to the users. Okay, users could be a business user or kind of a CEO of your company or your manager or whatever, right? Whosoever needs the data. Okay, now we have covered these 4 points. Now you can see there are 2 points in orange color. What does these means? Data analytics and data visualization. See, these 2 activities are typically out of the scope of data engineer, but sometimes it comes in scope of data engineer. So it's kind of an overlap activities. Of these kind of activities are overlapping, right? So a data engineer may not be able to do data visualization. Okay, but sometimes it is required that a data engineer should know data visualization also, or a data engineer should know a basic kind of data analytics or statistics, right? So these are 2 kind of activities which are good to have if you are planning to switch to a data engineer role, or you are already a data engineer. It is an add-on for you to know data analytics and data visualization. Okay, Data analytics is like analyzing the data and giving some insights to the business. And data visualization is like creating charts out of it, graph charts, right? Graphs, charts like bar graph, pie chart, and all those kind of charts to, to provide some better insights to the business. Okay. Towards the end, we see machine learning and decision making. Okay. So machine learning is a very, very, very vast topic, and it is very advanced topic. Okay. So if you're just trying to start your career in data, I would not recommend you to, jump directly into machine learning. Okay. Because machine learning has a lot of things, and you need to understand how data is stored, what kind of technologies that you can use with data, and then you should go for machine learning. But if you already have that kind of a knowledge base, then you definitely can, make your career in machine learning as a data scientist or machine learning engineer. Okay, so we'll keep machine learning part there, and then we'll move to decision making. So once the machine learning has been done and data is presented to the business owners can make decisions accordingly. Okay, so this is a typical, flow of data. And I have also mentioned what kind of activities that data engineer does, and what kind of activity, particular machine learning engineer or data scientist may do. Okay, but for data engineering, these are the things that data engineers should be knowing very well. Okay. So now we are going to talk about some career choices that we may have as a data engineer. Okay. So data engineering is a very, very, very vast thing. It's not like you learn certain technologies and you will be a very, very good data engineer. For an entry point, you should be knowing at least, bare minimum technologies to get an entry level job. But it's like a ever growing field, and it's like every day new technologies and new tools are coming up. And if you really want to be successful data engineer, you have to know about these tools and technologies along the way. Okay. Now, these are the career choices. Typically a database or data warehouse expert. So you could be, thinking to become a data warehouse or database expert. You can be, looking for a career in data analytics. So you can go for data analytics courses, or, you can go for data analytics certificates, and try to build a career there. And then typically for data engineer, big data technologies is like a boom. So, it's like nowadays every company and every, startups, every kind of an organization focuses on big data technologies, right? Because they may be somehow dealing with these technologies like Hadoop and Spark. Then we may have cloud data technologies, like there are different cloud providers like Google Cloud, Azure, AWS. So they have different kind of or different set of tools which a data engineer uses, right? So these technologies, if you know, it will, just skyrocket your chances to land a good job in any of the FANG companies, or, any of the MNCs or big fours, if you know any of these cloud very well. Then we may have business intelligence as a career option, where you have to do, basic data visualizations. You may have to get insights out of the data. Like there are different tools for it, like Power BI is a tool, Looker is a tool, Tableau is a tool, right? So you can also get expertise on these tools, and it has a promising career as well. And at the end, though this is not data science and machine learning is way different from data engineering, what a data engineer does. But nowadays, data engineers are expected to know a little bit of machine learning, and that is a fact. So at Google, we encourage our data engineers to to understand machine learning concepts, and it is a required skill. Okay. Okay, so our next topic, our next section is skills required to be a data engineer. Okay, now we understand what is data engineering, what is data, how data is captured, what are the career choices that the aspiring data engineer can have, or aspiring data enthusiast can have. We will be discussing the skills which are required for a data engineer. Okay. Now, these skills are very, very important if you want to start your career as a data engineer or data scientist, or analyst or whatnot, right? These skills are very, very important. So first thing is database, data warehouse, or SQL. Okay, so I will reiterate this thing. SQL is a must-know skill. Okay, you cannot make a career out of data if you don't know SQL. Okay, so it's a fact, and it's it cannot be negative. You have to learn SQL at any cost. Now, SQL is like a kind of scripting language which runs on databases and data warehouses. Now, to be a data engineer, you may need to know what is a database system, how data is stored in database system. So database is basically a store where you can store your data in row columnar format. Okay, it's like a table format where we will be having rows and columns of data. Okay, then in typically any of the database system, whether it be a SQL server, it be a Postgres, it be a let's say Redshift or Synapse or whatever database or data warehouse it is, SQL is always required there. Okay, you have to learn SQL, and you have then only you can work with databases and data warehouses. Now, database is a system where we store transactional data. Okay, so transactional data is like, let's say you go to a particular website. Let's say you go to some shopping website and you do some online shopping, right? So let's say you bought two products, like let's say you bought two shirts. Those details of your orders will be stored in some database. Okay, and if you bought two shirts, like there will be two records for you, like for one shirt, shirt one, shirt two. Okay, so I'm just giving you a very, very basic example. What is a transactional database is. So let's say you bought two shirts in your database. You have two entries, one for shirt one, another one for shirt two. Now, this is a transactional database. Okay, in transactional databases, what happens is you store data for each and every transaction. Okay, another thing is called a data warehouse. A data warehouse is also called analytical database. Okay, now in data warehouse, what happens is you store combined data. Okay, you store aggregated data, you store data for analytics, you store data for analysis, you store data to get insights, right? So in that particular kind of a data, you don't store transactions, you store combined transactions, right? So let's say if you bought two shirts in your data warehouse, how will you typically store that record? You will sum up those two shirts and you store them as a one purchase or one sale order or one purchase order, something like that, right? So in analytical databases or in data warehouses, you store process data or aggregated data. Okay, but in data warehouses also, we typically use SQL to query data, and you update data and whatnot, right? So SQL is definitely a must-know skill. Then there are some services provided by cloud providers like Google Cloud, Azure, and AWS. These are called cloud data warehouse services. Like Google Cloud provide BigQuery. So BigQuery is a data warehouse. Then Azure, Microsoft Azure provides Synapse Analytics. So it's again a data warehouse. And AWS provides Redshift, which is again a data warehouse. Okay, so typically you can start with a simple database. And then once you gain knowledge on database, you can definitely move to data warehouses. Okay, now there are some other tools and techniques which you may need to be a successful data engineer. So some people have this dilemma, they are not good in programming, right? So they ask this a question a lot of times. They ask like, do I need to learn programming to be a data engineer? Or do I need to learn programming to be a data scientist? Do I need to learn programming to be a machine learning engineer? Yes. At some point, at some level, you may have to learn programming. Programming is a must-know skill, but not like a software engineer. So software engineer has to do a lot of programming, but not as a data engineer. You don't have to do a lot of programming. And since there are so many cloud providers now, so these cloud providers provide those kind of services where you need to write kind of no code to low code, right? You don't have to write a lot of code to get your things done. So programming is a must-know skill, and that should be there with a data engineer, but it's not everything. Okay, so definitely if you are not very good in programming, you should start with Python. Python is very easy language. to start with, and it is like every tool and every cloud provider supports Python. So Python is, well-known language. Whether you want to start your career in data science or data engineering, Python is a must-know skill. So you can go for that. Then there are some big data tools like Hadoop or Spark. So these are the two most famous tools for big data technology. Well, now I would also illustrate this part. Like we use this term big data a lot. So what is big data? Big data is data which is present at a very large quantity. Okay, so let's say petabytes of data, terabytes of data. I'm not talking about gigabytes. I'm talking about terabytes, petabytes, right? These much data cannot be processed by a typical machine or typical server. You need distributed programming or distributed processing for that. And these distributed processing is, accomplished by Hadoop or Spark ecosystem. Okay, so these, once you understand SQL, once you understand Python, the next technologies that you should learn are Hadoop and Apache Spark. Okay, okay. So let's assume you started your journey in data engineering, and you now know a little bit of Hadoop, Spark, Python, SQL. Now the next thing for you is to move to cloud. Okay, because nowadays companies prefer those people who have experience with cloud. Okay, so people who know how Google Cloud Services work, how Microsoft Azure services work, how AWS services work. So it's better, to delay this thing. It's better to move into cloud early and quickly. Okay, so it's better to learn cloud fundamentals. It's better to learn data engineering platforms provided by these cloud service providers. So it's very easy and it's very, very important. Okay, so once you are good with SQL, once you are good with, let's say, Python, once you are good with little bit of knowledge required for Hadoop and Spark, and some cloud provider, cloud services as well, right? Like Dataproc, if you talk about Google Cloud, Dataproc, BigQuery, Dataflow, these are different kind of services which are provided by Google Cloud, which can be utilized in your role as a data engineer. These cloud providers also certify you to be a successful data engineer. Okay. Now, all the cloud providers provide some kind of a certificates. So what this certificate provides you is it gives you a credibility. Okay. So if you have a certification, it tells the employer, it tells the company for which you are applying for as a data engineer role, it tells them like you already know the technology. You are already, you already have worked on these technologies, and you know the technologies very well. Okay, so there are typically three kind of certificates that you should go for if you are starting your journey in data engineering. First is Google Cloud Professional Data Engineer certification. So it's a Google certification provided by Google, and it certifies that you are proficient data engineering, on Google Cloud Platform. Right. Then there is another cloud provider, Azure, which is Microsoft's Azure. So it's like data engineer associate certification with Azure. You can do this certification, and this will be really good for your career because it will tell your future employer, or the role you're applying for, or your interviewer, that you already know a lot of cloud services which are provided by Microsoft Azure. Okay. Similarly, AWS also provides different data engineering services certificates, and which tells the world like you already know these services on AWS. Okay, so these are typical examples of different certificates provided by different cloud providers. Now it's on us like which certificate or which cloud we would like to go for. But if generally they are kind of same service, they provide kind of a same services. So if you know the basics, if you know the SQL, Python, Hadoop, and Spark, you can plan for any of the cloud provider certificate. It's just your choice. It's not like Google Cloud is better than Azure, AWS is better than Azure. It's nothing like that. You can go for any cloud provider. You can go for any certificate. Okay, now towards the end of the session, we'll be discussing about how to land a job as a data engineer. So, you can learn SQL, you can learn Python, you can learn any tool and technology. But the eventual goal for you, if you are starting your career as a data engineer, the eventually you would like to get a job, right? You would like to get a job as a data engineer, and you want to be successful in as a data engineer, right? Now you can do that, but for that you need certain points in mind, right? Certain things in mind. So here are some last R and tips, I would say, for you to prepare well and get a good entry level job. Okay, so the things are like you need to prepare some basic programming skills. So I would again tell you, like, little programming knowledge is very required. It's not like you have to be a master or expert in programming, or need to learn a lot of complex programming algorithms, like those are typically asked in coding competitions or software engineering interviews. No, it's not like that. To get a good job as a data engineer, you should know a little bit of programming, but not programming is not everything. Okay, so you can start with Python, you can learn programming, and you can use HackerRank or Hacker as kind of a platform to sharp your skills on programming. Then you need strong hold or strong expertise in SQL and databases. That is very, very important. Again, you need to learn SQL very well. You need to have some knowledge of databases like SQL databases or NoSQL databases. You should go for that. Once you are done with these two things, you are good with Python, you're good with some programming skills, and you know SQL very well. You should start for big data technologies. And what are the best practices to work on these big data technologies? When we say big data technologies, typically there are two, like right now, which are very demanding in market, which is Hadoop and Spark. So you could go for these two. Okay, and then you should be very, very keen to go for a cloud data engineer certification. So in industry right now, these certifications are very, very valuable. So if you have any of these certificates, it means like you have the technology, you understand how certain things work, you understand how databases, data warehouses works, how pipelines are created, how streaming pipelines and batch pipelines are created. If you do any of the certification, you will get that knowledge base. So it's really good. It's really advisable to go for these kind of certifications. And the next thing that you should do is you should have a very, very good LinkedIn profile. Make sure, because nowadays companies try to reach out to you through your LinkedIn profile. So you should maintain your LinkedIn profile if you are a fresher, or if you are going for a career transition. Make sure you maintain your profile well. You update your certifications there. You update your summary really well there, and all that thing. So it's there are a lot of resources. There are a lot of courses, resources, and everything to how to actually maintain your LinkedIn profile and how to create your LinkedIn profile better. And then you need a good resume. So resume is like very first thing that our employer will look at. So your resume should not be more than 2 pages. It is good if you have a 1-page resume, and more like if you want to, at most it should be within 2 pages, not more than that. And you should write all the relevant information in resume. Once you're done with these two things, you are good to apply for different openings or different roles at different organizations or companies, and hopefully you will get a call back. But the thing is, you have to be strong during this period. It's sometimes what happens is, like, we do some courses, we get some skill set, but we are so kind of in a hurry to get a job quickly. Sometimes it takes time, and it happens with everyone. It is not like you build your resume today and you send it to a few employers and you'll be getting a job, or you'll be getting a call. It takes time. So I will tell you to be patient, and never give up, and always try harder, and definitely will land a good job. Okay, so that was it. Now we'll be having a Q&A session. I will quickly go through the questions that you guys have in the forum, and we'll try to answer those, and whatnot. Let's see. Okay, so Lalit is asking, what is a data point? So data point is typically, let's say, if you have a table, table of let's say students data. Okay, so student 1, student 2, student 3, student 4. all these students or a single row is a data point. Okay. And if you are talking about machine learning in machine learning and data science, it's the same thing. Single sample or example is called data point. Okay. Is there any tool for data generation? Data generation tools, yes, there are tools for data generation, but they're different tools and they are used for different kind of data. So let's say Google Analytics. Okay, so Google Analytics also generates data. YouTube, like video, if you record a video, it's also generating data, because a video, if you talk about a video is a data for you, right? A machine learning engineer or data engineer can process video. Images are also data, right? So yeah, so there are different tools to generate data, and there are different techniques to generate data as well, but those are out of the scope of data engineering. Okay, Venkat is asking delivery of data to users. Will the user be both business end users and data scientists or more? Yes. Data users of the data could be a data scientist, a business end user, or could be another data scientist or another data engineer. So these users have varied knowledge, and they could be anyone who want to utilize your data. So yeah. Okay. Then Lalit is asking, are there different teams for DE, DA, ML, and similarly? Yes, there are different teams for data engineering, data analysis, and machine learning. Definitely, there are different teams. But sometimes what happens is like when you go, when you become really senior, you have done a lot of data analysis, data engineering, machine learning. Sometimes these roles overlap. A single person can do all of these things as well, but generally they have different roles and different teams. Okay, Lalit is asking another question: how data is different from big data? Is only with respect to number of records or any other differences? Yes. So the major difference is big data is very big. It means it's humongous. It's huge. Okay. When I say huge, it's like terabytes or petabytes of data. So there is no definition for big data. It's like when the data is not, when you are not able to handle the data with a typical system or a normal system, okay, and then you have to use big data technologies or big data tools like Hadoop and Spark. Okay, but generally it is like some hundreds GBs or terabytes or petabytes of data. Then Kaushik is asking what level of SQL need, what topic to be most focused on for data analysis. So if you talk about data analysis, typically for data analysis, you need to understand all the basics like CRUD operations, joins, indexes, okay. And then if you talk about data warehousing, then you need to know star schema, Snowflake schema, data architecture, and everything in a data warehouse. So there is a lot of things, but for starters, you should be good with the fundamentals like CRUD operations, and your joins. Joins are very important. Groups, aggregations, these are very, very important for data analysis. Another question Lalit is asking, which is simpler to learn, BigQuery or Synapse or AWS? If you understand SQL pretty well, then I would say all of these will be, a playground for you. If you understand SQL very good, if you understand the basic SQL and database, then you can go for anything like BigQuery, SQL, Synapse, whatever you want. Okay, Levi is asking, what about knowledge of NoSQL? NoSQL is important. NoSQL is also important, but I did not keep NoSQL in this particular kind of a webinar because NoSQL is not something which you need to know to be a data engineer. Okay, NoSQL is something you can learn when you are good with these technologies. NoSQL you can go for. NoSQL is good. Okay, can you provide any free certification that you know of? I know Microsoft Azure provides free certifications, but for that you have to go for certain trainings that Microsoft provides. So you can go to Microsoft site and subscribe yourself there, and then you will start getting emails whenever there is a free session. You can go there, and sometimes they give you coupons for free certification. Even Google also does that. So you can go. You can just Google about it, and you will get some knowledge for that. I personally don't know anything where you can get the free certification, but yeah, sometimes the cloud providers provide these free certifications. Okay, Venkat is asking, does data reside in premise on-premise or in cloud? What is the reason why we need to learn cloud? Okay, so nowadays companies are moving to cloud. They earlier they used to store data on premise, but now they are moving to cloud. So it's better to be one step ahead and learn about cloud, because eventually you have to move to cloud. Nowadays all the data engineers are moving to cloud. So it's better to start early with cloud. If you have done some Python and data science recommendation for where how to cement your SQL knowledge, then if you know pandas where to cement Spark and this. Okay, so if you have done some Python, so for a good starter for SQL knowledge is W3 School's SQL course. You can go for that if you don't know anything about SQL. That is a very good starting point for understanding SQL. Understanding about SQL. And if you already know pandas, then yeah, if you know pandas, you would be doing good with PySpark. So you should start with Spark if you know pandas. Okay, sir, where to apply, say for data science roles? Only LinkedIn is enough, or should we apply for company's website? Definitely, you should apply for company websites as well, along with LinkedIn. Okay, you can go for other job portals like Naukri.com, Monster.com. But LinkedIn is very important, to be honest. What are the key points to keep in mind for collecting LinkedIn in profile? LinkedIn profile. Okay, so if you are talking about LinkedIn profile, mention all the skill set that you have, mention the certificates that you have, and write a good summary. Okay, and a very good profile picture. Profile picture should not be like kind of a party profile picture. Should be good. So yeah, I think that's enough. If you do that, it should help you to get a good LinkedIn profile. If have metadata CSV file, which is good to go, line by line, memory map, chunk by chunk, metadata CSV file. First thing is, like, if you have storing data in petas, you should not be storing it in CSV file, because processing a CSV file takes time. So if you are having petabytes of data, you should be storing in other formats like Parquet or ORC, Avro, these kind of file format. Chetan is asking, should we need to learn Hadoop? I believe Spark is good to go solution for big data. Yeah, Spark is good, but Spark works on Hadoop concepts as well. So it's good to understand Hadoop also. Okay. All right. So I think we are done with the questions. So I would really thank you all for attending this session, and I will also thank a lot to the coordinators for organizing such a good webinar. Yeah, and I'll hope I'll see you soon.
Thanks a lot, Abhishek. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. And the LinkedIn profile of the speaker is in the chat section. I hope you guys have filled in the feedback form. If you're not, I request you to please fill in the poll about feedbacks, as it helps us to conduct more such sessions. If you wish to conduct a webinar or facing difficulty in registering, connect with us at the link given in the session. And the recording of the session will be available within 2 days on our YouTube channel. We'll be back with another session of the data on 6th of March. The link is in the chat section. Till then, bye-bye and keep learning.